Hey guys, Mr. Milton here. Today we're going to talk about finding the volume of pyramids and cones. At the end of this video, you should be able to find the volume of a pyramid and a cone. Alright? Okay, so with pyramids and cones, we need to find the slant height to find the surface area. Remember that? And that was the height of the lateral face. With volume, we need the altitude. Altitude. Okay, which is the perpendicular segment from the vertex to the base. Okay, most of the time it goes through the center of the pyramid. Alright, so altitude. You see those altitudes drawn in. Alright, I've included an extension video in the column on Canvas. It's like 2 minutes and 30 seconds. Check that out, open that up, watch that before you go to this next section. I'll wait. Wait, yeah, pause me. Alright, probably did that by now. Okay, so the video starts with a pyramid and a prism with the same height and same base. Okay, it then shows that it takes 3 pyramids of water to fill the prism. Okay, therefore the volume of a pyramid is 1/3 the volume of the prism. That is where the formula for the volume of a pyramid comes from. Okay, so volume, remember, for a prism was the area of the base, the area of the base times the height. For pyramid, then it'll be 1/3 the area of the base times height. Okay, so not very much different at all. So let's get into it. Let's find the volume of this pyramid. Okay, so we need to find area of the base. We're already given the height. Excuse me. Alright, so the area of the base, it is a square base. So 8 times 8, which will give us the area of the base to be 64. The height is 9. Okay, and so now we can multiply this through. 64 times 3, that's 1/3, and that'll give us 192 centimeters squared. Or sorry, cubed. Volume is cubed. Okay. All right. Number 2. This is also a pyramid, different shape base, but that doesn't change it being a pyramid. So 1/3 the area of the base times height. The area of the base, we can find that in this case because it's a right triangle. 1/2 base times height, and so when we multiply that, that should give us 56. Okay, and so we have volume equals 1/3 56 times height 17. So 56 times 17 divided by 3, 1/3. And that'll give us 317, and I'll just say 1/3. No units attached here, so I'll just say units cubed. Okay. All right. So next example says, imagine that we have a prism. Imagine that we have a prism with an identical base as pyramid 1. Okay. What would the height of the prism have to be so that the prism has an equal volume with the pyramid? So we can do this a couple different ways, but we know that the volume will be 192. Okay, and the area of a prism is base times height. Okay, we already know it has the same base, identical base. So we say this base is 64. Okay, we don't know the height. Okay, and so now we can solve for height by dividing both sides by 64. 192 divided by 64. I believe that should give us 3. And so we'll see that that height would have to be 3. Okay, notice that the height would have to be 1/3 of the height of the pyramid, which makes sense because pyramids take up 1/3 less volume, so 1/3 less height for them to be the same. Alright, so a little bit of thinking how pyramids and prisms relate. Alright, cones. Cones are almost exactly the same as pyramids, except instead of the base being a polygon, it is a circle. Okay, so polygon, remember that can change to anything: triangle, square, hexagon, pentagon. Okay, but cones, the base is always a circle. Okay, therefore the formula for finding the volume of a cone, volume equals 1/3 area of the base. But now since the base is always the same, we just say pi r squared times height. So just like a cylinder, except a third of the volume. Alright, so we have that. Let's now go through and find the volume for these cones. Alright, so again, we need to find 1/3 the area of the base, which is pi. In this case, our radius is 10 squared times the height. Now, our height will be this perpendicular distance. Okay, it's the perpendicular distance. I know it goes this way and slanty, but it's the perpendicular distance. In this case, that's 16. Okay. All right. So now we use our information. We got 1/3, 100 pi times 16. 16 times 100 divided by 3. And that gives us 533 and 1/3. I'll just do 1600 over 3 pi centimeters cubed. And that's our volume. Okay. You bring in number 2 complete for me, please. Alright. Okay, so let's look at some more examples. It says a cone's base has a radius of 4 feet and a height of 6 feet. Okay, so we can plug that in here. Volume of the cone, 1/3, 4 squared pi, and the height of 6. So we have 16 pi, and that will give us 32 pi. 1/3 times 6 is 2, 2 times 16 is 32. Okay, what is the volume if the radius is doubled? Okay, so if we doubled that radius here, we can go through here. We doubled the radius, we would get 8 squared pi. Everything else is staying the same. So 64 pi, again, basically times 2 would give us 128 pi. Notice the difference is they doubled the radius, but the radius is square, so the volume is 4 times as big if the radius is doubled. Okay, what is the volume if the height is doubled? Okay, the height is a linear form, so we're always going back from 1, right? So we're saying, what if it's doubled from here? What if the height is doubled from here? Notice that the height is linear. Okay, it's not squared or anything else like that. So if we did everything else the same, 1/3, 16 pi times doubled height would be 12. That'd be 4 times 16, which would give us 64. Okay. Again, notice from here to here, since the height is only linear, it's times 2. From here to here, since the radius is square, then it's 4 times as big, even though it's doubled. Okay. Okay. And so, what is the volume if the radius is cut in half? So, now we're talking about radius. Okay. When it was doubled, it was 4 times as big. If it's cut in half, it should be 1/4 of it. So from here, I would think that it should be 8 pi. Let's see how that works out. we cut that radius in half, 1/3 2 squared pi times 6, that's 4 pi. 1/3 times 6 will give us 2. So 2 times 4 pi is 8 pi. Right? So should be 1/4. Okay? And then it says, what if the height's cut in half? Well, it makes sense, it's linear, so cut in half, that should make that 1/2. So I would assume from the beginning that it's 16 pi. Let's do the math and make sure. So if the height's cut in half, remember we're coming back from up here, we have 1/3 4 squared pi times 3. So 1/3 times 3 is 1, so we have 16 pi times 1, which is just 16 pi. Okay, so got to look at a lot of values there for the volume. Volume of a cone or a prism, or sorry, a cone or a pyramid should be pretty similar to volume of a prism or cylinder. It's just 1/3. Everything else stays the same. Okay. All right. Have a good one.